2050. Some think instead of sea level rise, warming oceans are increasing oceanic evaporation, which in turn leads to increased atmospheric moisture, which eventually falls as rain. Recent worldwide flooding and water devastation may well be ramifications of warming oceans we are already experiencing, which could be ameliorated by drawing down the ocean's thermal head by converting excess heat to carbon-free electrical power. The more electricity produced, the more the ocean would be cooled and the less would be the environmental consequences. In the words of the late Richard Smalley, a Nobel laureate in chemistry, to give 10 billion people as the projected population by the year 2050, the level of energy prosperity the developed world is used to, a couple of kilowatt hours per person, an additional 60 terawatts of power needs to be generated around the planet. An extremely worthwhile and inspirational investment of one's time is to view Dr. Smalley's full lecture titled Our Energy Challenge, available on this resource. Our overcharging oceans are a ready source of the replacement for oil Dr. Smalley points out we need to discover. In the course of producing energy from the oceans, you would limit their thermal expansion, which is expected to produce half of the sea level rise projected over the coming century. The other half of this rise will come from runoff from melting ice, and an excellent remedy for this would be to irrigate the world's hot deserts with an equivalent volume of water. Deserts are the only places on Earth capable of taking up such massive volumes of water, and their irrigation provides the means of remedying the greenhouse gas problem. As a result of land use changes, turning forests into grain fields and pasture, and the burning of fossil fuels, atmospheric CO2 levels are predicted to double in as little as the next 60 years. The concentration of CO2 in the atmosphere at the beginning of the Industrial Revolution was about 280 parts per million and has risen consistently since the 19th century to about 390 parts per million today. According to leading scientists, 350 parts per million is a safe upper limit, and anything over that for a sustained period will produce severe ramifications for our climate. It is expected that elevated atmospheric concentrations of CO2 and other greenhouse gases will facilitate greater storage of heat within the atmosphere, leading to enhanced surface temperatures and rapid climate change. The impact of unmitigated climate change will likely be economically expensive and environmentally hazardous. One of the most threatening outcomes will be sea level rise, as the water currently held in the world's glaciers melts, and this will accelerate as the Earth's surface temperatures rise. Reducing the risks of climate change requires sequestering atmospheric carbon dioxide, converting a portion of the thermal load being taken up by the oceans to other forms of energy, and/or the terrestrial taking up of much of the water that would otherwise cause the level of the oceans to rise and inundate populated coastal areas. Methods proposed to capture and store atmospheric carbon dioxide include storage in geologic formations, injection into the deep oceans, and induced uptake by phytoplankton. The limited capacity and duration, expense, and environmental outcomes of these methods are largely unresolved, making their utility uncertain. With respect to phytoplankton uptake, it is likely global warming is producing an exact opposite effect. Daniel Boyce of Dalhousie University postulates in the Nature article Global Phytoplankton Decline Over the Past Century, we are killing the base of the ocean's food chain at a rate of about 1% per year due to increasing ocean surface temperatures. What we think is happening is the oceans are becoming more stratified as the water warms, said Boyce. The plants need sunlight from above and